right? So why do I think that's good? It's well, active recall. Like I said last week, the test is recall. And by doing the test, you'll be recalling concepts from 2 weeks back. My plan is not to give a test for this week's. Like if I teach you something today, I won't test you on that. The test will be on things from the week before and the week before that. So that you're recalling that, so that you're not losing it, right? What happens is when you don't use that information, you're going to forget it. Everyone, this is a natural phenomenon, right? So hopefully doing that test, we can delay that forgetting. And then by delaying the forgetting, our learning becomes stronger. Cool? So that's my reasoning for wanting to introduce that, but it will take some time. But I'll keep you updated on that. Sounds good? So that would probably mean after class 11 to 11:20, a test. And if you need to leave, you can take it home and do it. But I recommend doing it here because then, you have a test like environment. Sounds good. Because I think that's one thing lacking in my class is that I don't get to see how well you're doing in test conditions. And I want to see you improve that as well, right? Because at the end of the day, these things I'm teaching you, you're going to apply it in a test, right? And you really, this is a sad thing, but you don't really use maths until you get out of high school, which is pretty sad. So all you ever use is in tests. So might as well do more tests, right? Now, that doesn't mean brainlessly doing endless amounts of tests. It's doing tests, reflecting on it, improving on it, right? And then hopefully when you go to uni, you might do something math related, like computer science or the straight maths, which is kind of torture. But
why are you doing?
I'm doing a couple. They're very proof heavy. It's a lot of their theorems and stuff, but it's honestly very good. It's tough, but it's very good. But yeah, even the pure maths is not, you don't use it as much, but like engineering, computer science, that's where the maths and physics get used really, right? And that's where you actually will be able to use it. But unfortunately, it's kind of tough to use maths other than the basic things like, calculating the change at calls or something, right? So that's the reason I think we should try to use the application as much as possible, which is testing. I'm going to try to bring that into this class. Sounds good? All right, awesome. All right, let's do a quick recap then. So again, recap is for you guys. You need to recall this information because if I just tell you, it's not the same. Okay, so try to think about the concepts from last week. First of all, gradient. Think about how it was defined. What was the formula for gradient? It's something over something. There's multiple different answers here. If possible, write all of them. I think that's 3. They're all pretty similar. So given one is, very good. But
is it changing the variable just have another one?
Oh, in that case, there's 4.
That's good.
Yeah, like you can switch the 2. Yeah, but also, what was the fundamental property of lines that we talked about? Think about what the fundamental property of lines was. It was 2 words. And then what are some 2 applications of it? 2 applications of the fundamental property of lines. Yep, so just write it out and if you're online, send me the answers on chat. For example, if you have a formula like, no, I'm going to make up a fake formula. I'm going to send the midpoint formula actually. X1 plus X2 over 2. You can send something like this if you want. That's not our answer, but you can format it like that for the gradient one. Recall, no notes. Right. Try without notes first. Then if you're stuck, use notes, right?
Did it have something to do with delta?
For the gradient formulas? Yes, one of the forms will. But honestly, if you get one and you're stuck on the others, move on. They're not as important. Getting all of the gradient ones is not as important.
I can't do it.
Delta means change. But again, you only need to get one. I recommend get one and move on, because it's if you spend all your time trying to get all the versions of this, you will miss out on the learning trying to recall this. So try to recall all of these. And if you're not sure what the applications are, try to recall back to the worksheet. So again, I'm just telling you how you should approach this. No notes at first, but just pure recall. And then if you're really stuck, give yourself about 10 seconds. If you could just come up with it, and then try notes. And for my hint for the application is the type of problems you solve with the gradient with that property. The gradient, that's good. And I'll give you a hint for the fundamental property of lines. It's something to do with the gradient of lines. In fact, that's half of it. One of the words is gradient. What about the gradient of lines? Not sure. Like you got the application, nothing, right? You don't know. You can say it in words without like the proper word. You can say like, because are you struggling to recall the correct word, like the proper terminology? If you don't need to get the proper terminology, you can describe the problem. The proper terminology starts with C. Might give you. So the fundamental property of lines, which is probably, sorry.
I don't know if I should say.
It's to do with.
Is it because it's ongoing?
Ongoing is pretty close.
Constant?
Which is important because much later on, you learn the gradient of things like this, which are like curves, aren't constant. This is unique to lines. Constant gradient. So I'm going to give that away. Fundamental property of lines is constant gradient. Which I know, probably, like the thing is, this is not as important to you right now because you only calculate the gradient of lines, like probably till year 10 or 11, right? So the only thing you'll relate to gradient will be of lines. So you'll assume that it's constant, but no, later on you'll learn. You can find the gradient of non-linear things. And those are not constant. And think about what you did with this property for the applications.
Is one just constant, just gradient?
Yeah. Oh no, for these ones?
Yeah.
No.
Then what are these for?
Those are the applications. Try to think of the applications. Those are the questions you did. types of questions you could solve with this property.
Oh,
It was in the homework.
can I just say like question 13?
No. The types of questions. What you did in those questions. No. Actually try to recall, yeah. Because this is pretty, it's powerful, right? Recall is powerful. I'm going to give you about another minute and a half, then I'll discuss. And I would love to see some responses for you guys online, but did you send it to the other chat, other account? Oh, yes, Sunudi, I just did see that you did send it to this. Yep, and your answer's spot on. Well done. By the way, from now on, let's send it to the host account.
Okay.
Yep, thank you. I renamed it the chat as well, so.
For 1 and 2, it's just like applications. You just need to talk about what kind of questions you can use stuff for.
Sorry, could you say that again?
I'm just a bit confused on what you have to do with 1 and 2.
Oh, yeah, so it is. So think about, with this property in mind, what sort of problems could you solve? So those are most of the questions in our worksheet last week, were those two types. Try to refer to note worksheet. But that's not a question type. Yeah, the Cartesian plane is within those questions. But what exactly was the question? You can discuss it. How about you guys do some discussion? Who knows what they are? X-intercepts you can do without that property. But yeah, good try, because you can just find the x-intercept by, if you're given an equation, you just let y equal 0. Because what x-intercept means is it's like when the line cuts the x-axis. And
the area of shapes.
Not quite. You can, but I think that's a more niche use. I think, yeah, you're right. That is a use.
Because like it's like,
yeah,
this is the square shape.
Yeah.
This like x and point to y and point is this find the gradient of this line to find the area.
No, exactly. Yeah. So you can do like, if it's here and you know the gradient's like 3, then you know what this y value is because of the gradient. Then you can do that. But that's a niche use case. I'll put that as 3. In fact, yeah, that's a good idea though. But do you see how you can use gradient to find the area? Because if the gradient's not given, so if the gradient's given, you only need 1 point, and you can find the other point and find this area of this like triangle here. But no, so the two main ones we want to focus on. That is good. That's a very interesting one. That's very nice. You can find area of shapes formed by line and the axis. So it's a triangle formed between the line and the 2 axes. Yeah, that's pretty cool. But the two main ones we're going to talk about was first the finding gradient of a line. Now it seems simple, but why was this important to find the gradient of a line? Well, actually, let's go back to gradient.
So we can find the midpoint.
No, just the gradient. Midpoint is separate part, I'd say. Gradient, there's a few formulas. It's y2 minus y1 over x2 minus x1, probably the most common. And then other formulas are more visual ways to think about it. So you got change in y over change in x. Also have rice over run. This is really your bread and butter. This is your most useful one. But these are like different ways to think about it that helps you with visualizing problems involving gradient. But here we already have a formula for gradient. So why do we need this property to find the gradient of a line? this is something Kushal said, which is that line has no endpoints and can be, right? Yeah, so because it has no endpoints, it goes forever. So then it's not like a gradient formula. Within the gradient formula, you need two endpoints, right? So that's the problem, right? The problem is for the gradient formula, you have endpoints. You have two endpoints, but for a line, it goes forever. So, but because of the constant property of constant gradient, what this means is if you pick any segment within this line,
it will still be the same.
And then because it's a segment, you've got two endpoints. So you can use those 2 points to calculate the gradient. Makes sense? That is why constant gradient helps you find the gradient of a line. So any 2 points, right? It does not matter. It will always be the same gradient. And second, what's the second property? So, sorry, second application. This is the slightly trickier question we did last week. Which is the
If it's like 3 over points, it's collinear.
Yeah. Is to check whether the 3 or more points are collinear. Well done. Thank you. So yeah, those are the applications. Any questions about that? No. That third one's pretty interesting. Thanks for that, Clash. That one is a bit of a more niche use case, but yeah, you absolutely can use it. Okay, awesome. Let's go to some recap problems. One. I want you to find the gradient
Of the triangle.
Oh, maybe we can make that a part B, but let's do. Let's do. No, let's keep it like this. It's not to scale. That's my first thing to you guys. It is absolutely not to scale.
That's crazy.
A.
Is this gonna be a decimal?
Yes, but I think fraction representing it as a fraction might be
Mixed
easier.
number or
No,
okay.
no need for mixed number. If you want, you can, but you don't have to. And pretty challenging. Find area of this is actually very hard.
It's like the 0C. It's like the center.
Oh, sorry, that's C is origin. I should probably just say I should say O instead of my bad. Yeah, that's O. Just ABO.
Wait, that's the
Actually, no, I'll be nice. I'll be nice after this. So let's do. Sorry if you've written it down. My apologies, but this will make part B easier. Yeah. So that's A. There's no more pink point here. So this is this. To find the gradient of the line, and then find the area of triangle ABO. But then question 2 is they can do part C. Determine whether one 5 fits on this line. Actually, no, I'll go. Sorry.
Wouldn't it just be 4 and 9?
What do you mean?
Because, like, for part A, for 4 and 9, right? Wouldn't that just be the answer for part B? Like, well, since you said, like, it's a constant gradient. No, sorry, finding a gradient of a line that doesn't have an endpoint, right?
Yeah.
So doesn't that mean that would just be 4, 9?
4 for the gradient.
Like when we're finding the area of the triangle, right? For point B, wouldn't that just be 4, 9?
No, so I've picked the point B to be the y-intercept. I've fixed that. So this is the B. So you will need to find ABO, which is these three, the triangle here. Just need to find this area.
So it's on the line, so the first point.
Yeah. So for B, it's 0 because it's on the y, on the line and the y. So it's the y-intercept of the line. Yep. The answer for A?
No, not for A, for B. Oh no, sorry. For C.
For C? Give me a second.
It's this, right?
Yeah. Have you done A and B?
I haven't done B. You just wrote that in.
Yeah, fair. No, you could. But you've done A then.
Yeah, I've done A.
Yeah, you're almost done. Very good.
Oh, wait.
Sorry, I switched it.
Yeah, I know. For A. We're finding like the gradient, right? Oh, wait, what was the original value? Because you changed that to be A again.
Oh, yes. With the original value, that's correct. Yes.
Okay, but then do I have to change it because
it's a different answer.
Okay, yeah.
Sorry.
I'll do it.
At least you can do it that way, but you can also do it without the equation. Think about the fundamental property.
We can simplify this, right?
Okay, so look at your formula again. So it's the slight mistake here. So it's y2 minus y1. What have you done here? Which value are you using? It's not opposite. You're doing which one's this? This is. That's fine. That's y2. What about this? This is an x value. This is x2. Yep. It's the second coordinate of a point is the value. I'll give you guys another 2.5 minutes, then we'll discuss.
How's your week been?
Busy. Uni started, but it's good. I think I'll get used to it next week. Hopefully I'll be fine.
Is the hackathon just like an outside event or is it for you?
It's not like a uni course, but it's like a lot of people in uni do it. In my degree, at least. So
Do you get like extra marks in your degree if you do that?
no, not extra marks. It just looks good for your resume and things like that.
Do you win money if you win?
Maybe I haven't checked, but there might be.
If there was, what would be an appropriate amount of money at that time?
This is pretty big. There could be around a K. Yeah. This is like the whole of Australia.
You have to quit.
No, wait, I'm not that good at coding.
Did they give you a prompt or anything?
I think they'll release the problem early on Friday. Then we got till Sunday to solve it. Or not solve, I come up with.
That one kid who just solved it.
Yeah, it's not like a math problem. It's like a real life problem. You gotta like come up with there's so many different solutions.
So you submit your answer on like the board or whatever, whichever answer like seems best fit to the problem. Is that like how it works?
No, so you submit your code because your code is running something. You create a project based on that problem. It's not like a one-word answer.
I thought it was just like no. I thought it was like because you said it's based on real life, right? Can you give me an example? Like, is it a situation or like?
Yeah, situation. Yeah, to be honest, this is my first hackathon, so I'm not exactly sure what it would be.
Because like I was thinking like I don't know.
No, I get what you mean.
I was like thinking of like a real like situation, like I don't know, going shopping or something, then something happens, blah blah blah.
Yeah. Does anyone need any help? So for B, go back to the fundamental property of line, which is constant gradient, right? If that point is on the line, the gradient between that point and any other point on the line should be not zero. It should be the original gradient of the line, which is what you got in it. Does that make sense? If it's not, then it's not on the line. That's the check. Make sense? Yes. C. Okay, so C. Think about this. B is on the line.
Did you figure it out?
You can find the coordinates of B by using the fact that it's on the line. If it's on the line, what's the gradient between A and B? 0.4. Oh wait, sorry. What's the answer to this one? What's the numbers you subtract?
0.
Y2 look correct. The issue with Y1. This is Y2. Y1 means the Y value of the first coordinate. That's X1.
That's X1 and 1.
Yep. X always means a first. It's a horizontal, so it's like each point has two values, X and Y. The one just means which point. It's the first point, X value, and the first point of Y value. So to do like B and C, you need to do A carefully. And yeah, if you're online, send me through your answers to the chat account.
What's the most embarrassing you've done recently?
Embarrassing thing.
that you've done recently. Yeah.
Give me some time. I feel like if I did something, I would probably try to forget it fast. That's why nothing's coming to me right now.
Okay, what's the most embarrassing thing you've had like your whole life?
That is a tough question. I'll need some time to think about that.
What about at school? What was the most embarrassing thing?
I'm honestly blanking right now.
The PlayStation.
Oh, that's not that embarrassing. It's a funny story. Yeah. I told my friend that
What
as well.
about your brother? What's the most embarrassing thing he's done? Don't say you're blanking again.
Yeah. I don't know. I might be in the math zone. Can't think of anything.
Pinch your thumb for 30 seconds and then switch to this side and pinch for 30 seconds.
What does that do?
It's meant to help clear your mind.
Oh, well, we need to do these problems, so let's do that later, maybe. Okay. So let's do the answers for these. So A, for finding gradient. So when you're finding gradient, you'll need to do rise over run or change in y over change in x, or the more formulaic way is y2 minus y1 over x2 minus x1. But you need to understand what each of these means. Y2 means the second y value of the second coordinate, and y1 is the y value of the first coordinate. So y2 is 9, y1 is 0, x2 is x of the second, which is 4, x1 is x of the first, which is minus 2. When you do these subtractions, you get 9 over 6, which is 3 over 2. And that is our gradient. Make sense? And you can even think about this visually. There's many ways to think about this, but keep it at that for now. Is that good, Danuki? Awesome. Part B. We need to determine whether 1, 5 fits on this line. Does anyone have any ideas about how they approach this?
I just thought that since 9 is like the highest, it's going up to like 1 and 5, would just be on the line.
But like you could have like a point like this, for instance, right? This is a bit above it, like, you know, this is still less than 9, but it's could be above the line. Your logic,
5, like, because it's going 1 to the side, right? And 4 is like bigger than that, so it's already there. And 9 is like the highest value.
so we're talking about x value of 1, right? So x value of 1 is like here.
Yeah.
So your argument is that because
And
this y,
5 up.
yeah, 5 up is less than like 9. So it's like, because it's like in between the two, the y value should be in between 0 and 9. Is that your argument?
Yeah.
That's pretty reasonable, but like I said, counterpoint. For example, here, this is still between 0 and 9, right? So it doesn't have to be. Even it could be below. So you have to be a bit more precise. So how do you determine it more precisely?
It has to be between 1 and 3. Sorry, it should be at 3. Wait, it's not.
We're only trying to determine whether this is on the line. No, we're not trying to find a point that's on the line. You just need to say yes or no with the reasons. Think about this. If this is on the line, what does that mean? And therefore, the gradient between this and like any other point on the line is equal to 3 over 2.
So that means you have to find 4, like the difference between 4 over 9 and 1 over 5.
Yep. Or you could also do.
5 and see if it equals to 3 over 2.
Yep. You could also do with A and that point. You could do -2, 0, and also 1, 5. Either of them would work. Why is it not collinear?
Because like 4 minus 1 is 3, right? That's the x value, 3. And then you have 9 minus 5, which is 4.
Okay.
5,
Yeah.
So it's 4. 3.
Yeah, so it's different. You've calculated that. But let's do the other one as well. So between -2, 0, and 1, 5, it will be the same. Not the same gradient, but it will be different if it's different. Right? So if you do the calculations here, you'll get m is equal to what? Can someone tell me the numbers I need to put into the formula? Based on these coordinates, I'm using -2, 0, and 1, 5.
Oh, so for y it would just be 0. Wait, is it 0?
0, yeah.
Oh.
That is- Try to visualize the values you put in your head. Can be helpful.
Minus 0 and
Yeah, y2 is 5 minus 0.
and then 1 minus 2.
Yeah, so it's 5 over 1 minus -2 is 3. So 5 over 3, which is clearly not equal to 3 over 2. Right? Because it's not equal to 3 over 2. They're not on the same line. Now, if you're a bit advanced and you know about equations of lines, you can do it this way as well. Which is what? Yeah, we're going to cover that today. But if you have done that in school before, you could also do it that way. And it works perfectly fine. But since I haven't taught that yet, I'm not going to teach that way. But feel free to use it. Although I do recommend practicing this. Because this one's a bit more logic related, right? Using logic. And C, finding the area of triangle ABO. This one's also pretty tricky in that you need to find B. How do you find B?
Wait, it's collinear because since it's on the line as well. So that means you have to just like do.
You can find the Y value by using the collinearity property. So you can use, for instance, A is -2, 0. And what's the way to represent B?
B is 0 something.
0 something. Let's call it
X.
Let's do Y, I think. Just let's more intuitive. It's fine to do X, of course. But I can get confused sometimes if I put X, so I'm gonna do Y. And you find Y based on the fact that what?
That is collinear.
Yeah. And if it's collinear, the gradient between these two is?
The same.
3 over 2. Yeah.
Oh, yeah.
So you can find gradient between these two. So you can go Y minus 0 over 0 minus -2, which is Y over 2. And you're going to say that's 3 over 2, right? Because then you solve for Y. So what's Y? You can multiply both sides by 2, or you can just see they're both over 2, so it must be 3. But also you can do more formally, you can just simply say Y is 3 by looking. That's fine. But you can also do multiply both sides by 2. You'll end up with the same thing because these 2's will cancel.
Can we do another question? Just
we're a bit tight for time.
Okay.
What I will do is I'll create another question. You can write it down and attempt it after class. Just recap if you need. Okay.
I have to leave 4 p.m. class. I can't say later than 11:30.
Oh, we'll finish early. We're not going over time today. We'll finish at 11. What I will recommend is if you can straight after class, you can stay here, spend 10 minutes trying to resolve this problem on your own without any help. So have this question written down. Actually, I'll put it on Discord as well. Take a screenshot, put it on Discord. Quick recap after class is great. Because you got help from me to solve some of these, right? So trying to do it on your own will really reinforce these concepts. Any questions about this though? No? All right, so we'll figure out the area now. So we know that this is 0, 3. B is 0, 3 now. Now, based on this, you can find the area because you got the height, based on the height. The height is what?
3.
Base is
2.
2. So you can do area is half times base times height.
Wouldn't it be negative though? Because it's negative 2.
We only consider length as positive.
Oh,
Yeah, it's just how far apart they are. It's negative 2 if you're considering direction and that matters in some way, but it does not matter. So yeah, gradient area is half times 2 times 3, which is just 3. Awesome. So I think best thing, honestly, I'm not even going to give you another problem. Try to solve this problem on your own after class. And it's actually a pretty good exercise. I tried something similar for my lectures and it was really helpful, right? Because you'll be surprised. It's still challenging because you got help along the way. Trying to do it without help is still a decent challenge where you'll get some learning, right?
wait, you know how you got 3 over 2? Would it still be the same even if we did it for like 4 over 9?
Yeah.
Okay. So you can go any direction.
Good question. Yeah, that does work. You can check it out if you want. I'll actually show you if you want. So you do gradient now. You go 9 minus y over 4 minus 0 is 3 over 2. 9 minus y over 4 is 3 over 2. How do you solve this?
Wouldn't it just be 6 over 4? Because 4 minus 0 is just 4.
Yes, yep, exactly. We can also do it this way. Multiply both sides by 4. And you get 9 minus y equals 3 over 2 times 4, which is 6. 9 minus y is 6, so y is 3. Same answer. Yeah, so that is the collinearity property, the constant gradient property coming in. So now do you trust it a little more because you've seen that it does work? All right, cool. Yeah. So yeah, I'm not going to give any more recap problems, but what I will recommend straight after class, I recommend sticking around if you can. If you need to go, of course, I understand, right? The class officially ends at 11, so if you need to go, you can go. But spend 5 minutes or 10 minutes trying to first recap everything. Just quickly write down whatever you remember from the class, then attempt this problem on your own. Trying to recall the ideas we discussed in class today. Very powerful. Awesome. Yeah, let's keep going on to today's content now. So today's content is going to be on finding the equation of lines. And what you'll be given in these types of problems is you'll be given a line and 2 of its points. I don't know, let's actually go with something similar to what we just saw. So let's say we're given this line. -2, 0, 0, 4, right? Pass it through those 2 points. And honestly, once you know 2 points on a line, that's enough to know everything about the line because constant gradient. Now we need to find the equation of the line that passes through these 2 points. So let's try to brainstorm some ideas. For a minute, I'm going to give you a minute. Try to write down every single possible idea you could think about how you could potentially find the equation of this line.
The equation.
Yeah. Equation is a general rule for a line. For example, a line. Actually, I'll give you an understanding of this. Right. Let's say this line could have equation y equals 3x plus 4. This line here. So it's a rule relating how the y and the x values of this line relate to each other. Make sense?
3x is. Yeah.
So think about how you could potentially get there. I know you'll struggle because you have no idea how to get there, but just come up with any ideas. Use all the concepts we know from beforehand. Whatever, just write down for a minute, and then I'm not expecting you to be correct unless you've probably done this before. It's just about coming up with whatever ideas you think of.
While we're doing this, can you think of the embarrassing moment?
I'll let it. Give me a second.
See, I'm following my goal. For this.
Give me a second.
Constant gradient B1.
That's an important idea.
Because it's like, you said no matter where the points on the line, it will still be the same value.
Yes, same gradient. Yep, exactly. Actually, that is going to be used. Maybe not in the way you think, but it will be used. Okay, cool. So what are some ideas you've come up with? Now, trust me, you don't need to be correct here. Like, I'm deliberately giving you a hard task just so that you can put in some effort and have an idea of what the problem is before I talk about it. Do you understand some things about this now? Like, what are some thoughts you've had about this? Just share. There's no right or wrong answer.
Because, so basically, relating back to the other problem, the recap problem, you know how you said like 3/2, right? For that.
Yep. Gradient of this. Yep.
Gradient. You can find the gradient between the 0/4 or minus 2/0, and that means that it will still have to be the same gradient for the one above.
Yep. So you can find the gradient of the overall line just by these two. Good. That's a very important point, actually. Very good. Did anyone else write that as well? Or just put about it? Yeah. Yes. Good. So you can find the gradient of the line with it, and it's actually a very, very important step. Well done. Any other key ideas that you can notice here?
Midpoint.
Midpoint? Good try. But I don't think midpoint will come in as handy for this.
Constant.
Yes, absolutely. This is super important. Okay. So these are actually the only two ideas we need for this. So you got there, right? Now I'll show you how it connects together. Okay. So first, we can find the gradient of the line. How do you find the gradient of this line?
0 minus 2, and then 4 minus 0.
Which one's at the top?
The 4 minus 0 is on top, and then 0 minus 2 is on the top.
Yep, y2 minus y1 over x2 minus x1. So it's 4 over 2, which is
1. Sorry, 2.
2, yeah. So you can find the gradient of this line, first of all. That's actually half of the clue, half of the battle. No, maybe about a third, right?
That means you can do the same to find the top right. If the gradient of the line is 2, doesn't. Are you trying to find the endpoint or no?
There's no endpoint. It goes forever. So you're just trying to find the equations. You're trying to find what is the relationship between x and y on this line. That might be a new idea because I don't think you've seen equations necessarily before, right? So that's our goal. Okay, but these are the ideas. No other ideas needed. Okay, this one might be a little bit weird, but we can use the idea of constant gradient with a little bit of a creative way to think about it, which is, everyone listen up here. This is important. Let's think of a general point, x, y, on this line. So this could be anywhere on the line because x and y can change.
Yeah, that's what I'm saying. Like, so it could be anywhere on the line, but it would still have to be like the same.
Yes,
Same,
yes.
Like, too.
Exactly, yeah.
That's what I'm like.
Yeah, do you think of this as well?
Yeah.
Yeah, okay, spot on, beautiful. Yeah, that's the idea. And what do you do now with it?
I'm not sure. I was just.
Oh yeah, but
it's like if it's x and y, whatever. Like if it's some point on the line, it has to still be the same, right?
Same what?
The same gradient.
You do that. You calculate the gradient, and let that equal 2.
Oh wait, so wouldn't you just do
You can pick
4 minus
x.
Y.
So you can do x. Which are the 2 points you're doing? So the pink point, call it C.
C and B.
Yeah, we could also do C and A. Doesn't matter. But what you do is you pick the gradient between C and B, calculate that, and let that equal, which is 2. And that's the rule, right? Because if xy is on the line, the gradient between that and like 0, 4, which we already know is on the line, is going to be 2. That's the property of constant gradient. Now, that's a very important idea. Does anyone have any confusions about that? So this is weird because, you have 2 variables. You're not really solving for a variable, but you're trying to calculate. So you're trying to find gradient between 0, 4, and xy. And you know it's going to be equal to 2 because the point is on the line. So how do you calculate this? You go y minus 4 over x minus 0. This is y2, y1, x2, x1. Following? And that's equal to what? Someone that's not Nikesh? He's doing very well and answering a lot of questions. 2, because that's what we found in the first step. And then you rearrange this equation. You're not solving for anything because, look, you want the rule in terms of y and x. Is rearrange it. And what you really ideally want, okay, if you just do this, you're correct. Y minus 4 over x is 2. You're correct. But what you don't want to do it necessarily all the time. Sorry, this is correct, but this is not nice. So what you want to do is make y the subject. That's just the convention we're used to in maths. So how do you make y the subject here? Because if you put the answer as this, you'll probably still get marks. Or it depends on the teacher. They might be like very strict.
Just times by y.
Times by y. Okay, let's see.
No, we multiply by x, right?
Yeah. So that's, I think, problem with y is it doesn't really get rid of our issue. Our issue is the denominator being x. So you multiply by x.
So 2x and then just y minus 4 is 2x.
And then if I wanted to get y alone,
you want to add y. Add 4.
Add 4. 4 here, minus 4.
Oh, okay.
You want to move that, so plus 4. If you add y, look, you get y on this side, and you get another 2y. So like you're bringing y to both sides. So
wait, but if you just add y, wouldn't that just calculate out and be 4 equals 2x?
No, you have plus y here already. If you minus y, Yes.
Oh yeah, never mind.
Yeah.
Sorry.
But then you get negative 4 as 2x minus y, which is correct, right? All of these are correct.
No, I was
Yeah.
thinking of it like as minus y.
Oh yeah. Yeah.
Okay.
So our answer is y is 2x plus 4. Any questions about that? And actually, a good way to check whether this is correct, how do you check?
You can check with like any of the other points.
Yeah, we have 2 points here. Check with those. So let's check 0, 4. You sub 0, 4 in. So the way you do it, you just sub the x value and then see if you get the correct y. So you sub actually 0, not. You don't sub the entire thing, you just sub 0 and see if you will get 4. So sub x equals 0. When you do that, you get y is 2 times 0 plus 4, which is 0 plus 4, which is 4, which is what we want. Cool. Now, can you check on your own whether negative 2, 0 also satisfies this rule?
Could you zoom in a bit?
Oh, sorry. Yes. Checked. Okay, you're still doing it. I'll give you another 30 seconds-ish. So what you need to do is sub. Look what I did. I sub x value. Yeah. Sub the x value, which is what? Negative 2. And see if you get the y value you need, which is 0.
So you're just trying to get the y value, right?
Yeah.
Okay.
If you want, you can sub the y value and get the x value, but that's way slower. Sub x is negative 2. So you get y is 2 times negative 2 plus 4, which is negative 4 plus 4, which is 0. Awesome. Did everyone get this?
Oh, so you're substituting the y value into the equation and just using the x value.
No, I subbed in to the x value.
Yeah, no. You subbed in the x value, right? But you're still using y equals 2x plus 4.
Yeah, exactly. It's using the equation.
Yeah.
But you're trying to see if the point we found, which is negative 2, 0 on the line. So the point given to us, is follows this rule. So we need to use the rule.
No,
yeah.
I got a bit confused.
Oh, no, that's all good. Yeah. So we're just starting. It's fine to be confused. It's good to clarify those now.
All right. We're going to take a break.
Yeah, we'll take a break now. Come back and practice this.
Embarrassing story.
Yeah, I don't have it on me. I'm probably not going to be able to think of it this class. I will try to think about it.
Do your caps always turn out like this?
Yeah. It's because of tennis, right?
Yeah.
No, I don't. I have the one hat, like this cap I play with tennis with. That's why it's a little dirty. But the one I take to uni, I don't. Like
I've
tennis
had
with
this
it.
since 2024 at the start, and it's kind of wrecked over 1 year. The score kept even worse.
It's sun damage. It's pretty bad. Sun and sweat. Bad combination.
Just washing doesn't help it. You need to put like bleach, don't you?
I think so.
Yeah. I'm just gonna have to.
Yeah, all good. Is anything? Have you guys done anything fun over the last few weeks? Just school.
Yeah.
Yeah, makes sense. Are you guys? Do you guys watch sports or do you watch TV and stuff more?
TV. Yeah.
Okay. Like TV or like Netflix?
Probably Netflix. Not
Oh,
TV,
okay,
actually.
yeah. I don't think many people even watch TV anymore.
Yeah.
Okay, here's an important question: TV or movies?
TV.
TV.
Yeah.
You? Yeah, TV. Fair. What about you guys online? TV or movies?
Depends on
Fair. What do you watch more though?
what.
TV.
There's no. I feel like I watched every TV series and movie on Netflix.
What's your favorite?
I'm not allowed to watch MA.
Sorry, I'm not gonna tell your parents. Oh, you haven't, or you?
I'm not allowed to.
Oh, okay. I thought you said you were like.
It's rarely that I ever get permission to watch it. They only allow like fantasy violence and stuff.
Oh, okay. No, that's fair. I mean, you're what? In 2 years, you can watch it. Yeah. Can you watch M?
Yeah, I can watch them.
Yeah.
But I still need to check it.
Oh, okay. That's probably good. I mean, it doesn't matter. Like, they don't need to have a high rating to be good. Like, thing is, some shows are just good. They just need to become have like MA15 or R18 because the things they explore are, well, like, that's really good.
All my
PG.
friends are just watching like all of this and they're like, "Oh, have you watched this?"
Which ones?
I don't know. They're watching I think it's The Rookie and stuff.
Oh, The Rookie.
The Rookie, and then
Oh,
I
yeah.
don't remember what else they're watching.
Is that MA15?
Yeah, I think it's.
Oh, because it's caught one. Yeah, of course. They have to explore those,
Yeah.
Rookie?
I watched one episode and it's fine.
Yeah, the thing is,
I don't understand.
it's not MA15 plus because it's like they're constantly swearing and saying bad stuff.
No, it's not
It's
that.
like
It's because of the stuff like drugs and stuff.
Yeah, stuff and police violence. They're exploring very pretty heavy topics.
I mean, it happens in real life, so.
Yeah. I watched it.
What age did you start watching MA?
12.
I think I've only started watching. I feel like I've only watched 2 MA movies. That's it.
Wait, is Kingsman MA? That's what I first remember.
Yeah, that was one of them.
It's really funny. Yeah, that's one of my first ones. It was so good.
You know the Kingsman 3 is coming up.
Oh, is it? I didn't like two though.
2 was
Yeah,
was
one
crazy.
was sick. Oh, or two. Oh shit. Have you watched two?
The sleight of hand trick when he tricked the guy. Remember that guy, the double dealing, and they had that explosive thing in the neck?
I've kind of forgotten. Man, I need to watch it again.
You
Have you
know,
watched two then?
Yeah.
Oh yeah, I know one scene on that. You should. I don't want to talk about it.
Oh,
Yeah.
I was like, wait, the fighting scene? Which scene?
No,
You
no.
finally realizing.
It maybe you can think of it as fighting.
You have to describe it like that, okay. First movie.
Okay. Has anyone else watched Kingsman? We don't watch it for a couple of years.
First one we watched at a party. The
Like-
adults were like in one section.
Yep.
And we were just in the living room.
Watching Kingsman?
Yeah.
Oh,
And then it came to that scene, and we were like, oh.
yeah. We kind of did that with my friends, but with Wolf of Wall Street. It's not. Don't watch that movie though. I think it's R.
Our
It's
parents wouldn't let me even like view an R-rated movie, I think.
yeah. It's honestly don't watch it. It's not even like it. It's overrated. I don't like the guy. It's based on the guy called Jordan Belfort, and they basically give him free marketing for his scams. So screw that guy.
What's the best movie you've ever watched, though?
Oh, wait. Let me check my letterbox. Yeah, you know what? Yeah, it's important. I'll check my letterbox and then we'll get started. I don't watch as much movies as TV, so that's why it's a bit harder for me.
TV, there's just like shows that just go on there.
Yeah.
Young Sheldon used to go on there, didn't he?
Oh, my mom loves that.
Young Sheldon.
That's my reviews.
Oh yeah, have you seen them in real life?
The cast?
Yeah, the cast in real life.
Uh,
There's so contrast to their characters.
really?
They're not like their characters at all. Except for like the guy who played George.
Oh,
He has that really deep southern accent.
I can't find my favorite movie, but I did see my latest review, which was Captain America: Brave New World. I gave it 1 out of 5 stars. It's pretty bad.
I haven't seen that stuff.
It's good.
Why? What happened in it? I don't care if you spoil
It's
it.
boring. It's just nothing.
What happened? Was it just a bunch of fight scenes?
Yeah, but like, dude, when the movie ended, I thought, oh, when's the action gonna happen? And the movie ended. Like, I'm like, when's the plot gonna happen? But the movie's already over.
What? Hey, what? That's just boring. There's no point of going to it.
It's so boring. Yeah,
It's like ending on a cliffhanger.
you can't even say that because I don't care about it. Cliffhanger.
You're engaged in the movie and then they just end up in it.
That's Spider-Man Into the Spider-Verse. Oh,
I hate that.
it was so good, and then they just like,
they decided like
yeah,
end of movie.
and then they delayed production.
Pay more money to find out what happened.
Yeah, exactly. Like,
That's just what they do because they know like, wait a minute, we can get more money.
yeah, and then no, but I hate it. First of all, like it just overall, I don't like it. But if you do that,
the second movie was good.
it hasn't come out yet.
But not the second movie, the third movie. Because there's the first one where he finds about his powers. Oh yeah, second movie, that's Across the Spider-Verse.
Yeah.
And then
And that's where the cliffhanger happened.
yeah, and then
But
next is Beyond the Spider-Verse.
yeah, but the problem is they were meant to release Beyond in 2024, but it's been delayed by like 3 years. So okay, anyway, we've been yapping
the fact
for
that he was hanging on a bag at the end,
yeah.
and then he gets off. Crazy.
All right. Anyway, let's get started. So first thing, I'm gonna mention a couple observations from this, and then we'll practice some problems. Okay. So first observation: Actually, if you look at this coefficient of x here, do you see anything special about that value?
Anything special?
Yeah, the coefficient of x, which is what? 2, right? The coefficient of x is 2. Anything special about that? It's the gradient. Make sense? So if you wanted to, and this happens in general as well, and we're gonna use this property to come up with a shortcut method to calculate gradient. But first, let's practice another question. Okay? Let's practice, but keep that in the back of your mind. So we're gonna come back to that. Okay, so the coefficient of x here is the gradient. And check if that's true in the next example as well. Let's consider this line. Let's do keep it nice. Not to scale again. Find the Find the equation of this line.
Like the equation.
Remember the steps. Try to recall the steps we did before.
Could I have a cookie?
Try without it first.
I did.
You didn't write anything down. You can't say you tried without writing.
In my brain.
No. You need to try with writing first. Then if you're not sure, you can have a quick look.
Am I doing better with my goal?
Yeah.
Somewhat.
I think you asked the question as soon as you finished your work, though. Even if someone else.
Yeah, I mean, kind of said.
I mean, you're not affecting your learning, which is good.
Am I affecting that?
I don't know, but it's not. You're doing better, right? You're not. You focus more, right?
We're just trying to find like the what do you call it? The gradient between those two, right?
Gradient between. That's one of the steps.
Is it like we're just trying to find the rising end of this?
We're trying to find the equation of the line, but gradient might be a step along the way. Remember, like the equation of that line was y equals 2x plus 4.
Oh.
We're just trying to get to that equation, that type of equation for this as well. Actually, do you want me to be nicer, or are you already doing it with these numbers? Keep it? Okay. I'll give you another point if you haven't started yet. Might be a little easier. 0, 4. These are all on the same line. If you're doing the question already, this will, with the other points, it will be the same answer still. So don't worry about changing it up with that. But if you want to be a little bit easier, these are better numbers.
You look good.
Yep.
Could you go back to the thing, please? Yeah. Could you go down a bit?
You're just checking your answer. Good. Yeah, your answer for the first one is correct, but yeah, it's very good to check. Okay, so you only use. Oh, is this your attempt?
Yeah, because like you added 0, 4, which is the same as the last one.
But that doesn't mean it's the same equation. Does it work with 1/7? You just want to get away with it.
I was like, oh, he put the same. You thought about it. Do you think about it? Okay.
Okay, cool. This calculation is very important because that forms the foundation of all of our future calculations, right? So make sure not to make silly mistakes. What's 1 minus negative 1?
0.
No, 1 minus negative 1. 1 minus 1 is 0. Minus like plus 2. That changes our overall answer to the gradient. So what's that? Yep. Think about the logical progression of these steps. Right. So what do we do first? Then what do we do based on that information?
Like I got the 0, 4 and y, x, y.
Yep.
Doesn't that mean you just do it with y?
Yeah, that's equal to what though?
Wait, could you go back to like the graph we did before? Yeah.
What's the difference here?
Oh, the gradient of the line.
Yeah.
So we still have the gradient of the line too. That means y. Okay. So the first like constant gradient. So that part 0, 4 and x and y. So you still do y minus 4 over x minus 0 equals the gradient of the line, which is 3. Yeah. Okay. That's what it is.
Yeah. We make sure to be accurate on that first step. Because finding the gradient, that's the most important because that forms the foundation of all the other calculations. let's go through this. So we're trying to find the gradient of the line. You can do it without looking.
No, I can't.
You can.
Please.
No, you can't.
2 seconds.
Recall. Don't avoid difficulty. This is called desirable difficulty. Doing it without any help. Look at you writing away. You're fine without it. No. Okay. The first thing we need to do is find gradient. And that's what everyone did. That was very good. Can someone share me the gradient value? Yep. And which points did you use?
Like 1/7.
Yep. It doesn't matter which one you use, right? Any of them will work. But if you do this, you'll get 7 minus 1 over 1 minus negative 1. Which is 6. Oops. 6 over 2. Which is 3. Okay, and then now that you found the gradient, now think about a general point on this line. XY, right? And what we need is, if this is on the line, what do we know about this point XY?
That it's collinear.
Collinear, and therefore?
They have the same gradient.
With?
What coordinate?
Yep, any of the 3 coordinates that's already on the line. We need to use a point already on the line. So the gradient between XY and any of the 3 other points is 3. So let's use find the rule. So let's check the table. Right, so you want to use the general point, and Duniki, what point do you want to use? Yeah, probably the easiest one. That's good. Right, and then what's my gradient here? Yes, but what about like in terms of x and y on the other side? Yeah. So what I'm like this step here, I'm trying to find the gradient between these two, and then I equate that to 3. If you use the gradient formula, what's the gradient between these two? You just like you're not gonna get a number. You just do it with the variable. So you do y minus, or 4 minus y. Actually, let's switch these two. Let's make this y2, because that will make our calculations nicer. Okay. So what's y2 and y1, Daniki? Y2 and like in this between these 2 points. Yep. Awesome. And then x2. Awesome. And this is based on your rule. Y minus 4 over x is 3. And you rearrange to make y the subject. When you do that, you get y is 3x minus 4. Oh, sorry, plus 4. I'll do it slowly if you want. Y minus 4 is 3x because I multiply both sides by 3. Sorry, by x. Then I add 4 to both sides. Then I get y is 3x plus 4. All right. Okay, that's the process. Yep, that's the equation. Y equals 3x plus 4.
Okay. Oh, yeah.
Yep. Checking is up to you, and I do recommend it. But for the sake of time, I'm not going to do that here. What I will do instead is what I'm going to get you to do is actually, I'm going to give you a shortcut. Although I do want you to practice this method because this method is important. So come back to here. Is there anything special about this number here? It's the gradient. You calculated 3 and it's shrinking up again. And we saw that before as well. Here, right? We got 2 as the coefficient of x. Niklesh, pay attention. 2 is the coefficient of x, but 2 is also the gradient. So you can probably tell that it's starting to become a pattern. And that is always the case. It's the general rule. Do you know why? Think about this.
Because without the gradient, we wouldn't be able to find the coordinates of the line, or they wouldn't be equal.
Yes, but why is it the coefficient exactly?
Because it wouldn't be collinear.
Yes, I think these are points that are true, but we can prove more concretely. We're trying to prove it more concretely why it's the case, right? I think you're not wrong. You are explaining like the underlying reason behind this, but usually you can show this with algebra. Now think about it in general, right? What you're doing is, let's say you know a point A, B is on the line, right? That's what's happening in general. And then you also want the general point X, Y. You know that, right? And then you know the gradient between them is M. What is the gradient between these two if you use the gradient formula? Y minus B over X minus A. Now I know it seems complex. Just follow with me for Niklash.
I'm not sorry. It's just that there's air bubbles over.
Oh, okay. Yep.
Like they just, otherwise we get stuck in the front.
Yeah, let me try to. Hopefully, they won't be gone. They'll still be. Can you get rid of them after?
Yeah.
Okay. So here we have this. You following with me so far? I know there's A's and B's, but then I know they're variables, but pretend they're constants. Right? Pretend we know them, because this is just general things, because otherwise I have to give you fixed points, but I want to show you the general case. So you're fine with the A and B? They're not variables. They're just constants. We don't know what they are. They're called parameters. If they're constants you don't know about, they're parameters. So look, if you try to rearrange this now, what happens?
Like parameters or parameters?
Parameters. So P-A-R-A. If you rearrange to make y the subject, you multiply by. What do we multiply by? Yep, x minus a. Not x, because that doesn't get rid of the denominator. We have a reason for doing all of these things. And look, when you do this, you get y minus b is m times x minus a. And let's say you expand this bracket, you get mx minus ma. And then you'll add b or something, but that won't affect the x, right? So if you just look at the x right now, the gradient is the coefficient of x in general, because when you multiply this x minus a with the m, you get the gradient as the coefficient of x. Make sense? That's what happened here. You multiplied x minus 0, which is just x by 3. So the coefficient of x became the gradient. Do you see that? So because of this, what you can do as a shortcut is, instead of using the fundamental property, you can use the fact that all of the equations of a line looks like this. It's going to be y equals mx plus some constant. Do you see that? Now this might be the famous formula or equation you might have skimmed across. Right? You see this in all your textbooks. But this is where it comes from. Y equals mx plus c, where m is the gradient of the line. So how
just gradient, right?
M is gradient, yeah. So with this information, the way you can find this equation is, you still do the first step as the same. You do this, find the gradient, which is 3. Then you know y is 3x plus c. But now you need to find c. How do you find c?
Constant, right?
Yeah. I'm applying this new way to solve the equation to this graph still.
Oh, constant gradient, right?
No, we sort of avoiding that complication. It's good.
I like to see behind this.
Yeah, I did. Trying to get it back. Actually, are you following so far?
Yeah.
So now we need to find c. So instead of using the constant gradient property, we're going to just sub a point. Any point. I'm going to do 1, 7. Although that is probably unnecessary. 0, 4 is easier. I'm going to do 1, 7. Then what happens? 7 is 3 times 1 plus c. I'll get a one variable equation for c, which I can solve easily. 7 is 3 plus c, so c is equal to 4. Minus 3 from both sides. And that means because c is 4, my equation is y is 3x plus 4, which is identical to what I got with the more complicated gradient method. Do you see that? So you can use the shortcut, which is y equals mx plus c. Every single equation of a line follows this form. And you can find m using just 2 points. Then you can find c by subbing one of the 2 points. Cool? And that is the second more efficient way to calculate the gradient of a line. Now that said, you skip all of the logic behind it. This is the actual general way to this is the proper way, right? When you use the constant gradient property. But this is a faster method. So what I want you to do is be comfortable in both. Reason? Well, this is the foundation. If you forget the foundation, the concept is easy to forget. If you have the foundation in mind, it's much easier to forget it and then recall it from first principles. Okay. Any questions about this? Now, can you apply this new method to this line we did at the very start? Try to think about. Right, so you still got the gradient as 2, but then you don't, instead of doing constant gradient, you use the y equals mx plus c formula to find the gradient, find the equation, and see if you end up with the same answer.
M just means gradient, right?
Yes.
Can I just ask why it's M?
Honestly, I'm not sure.
Why isn't it like G?
Let me actually research that.
Why is it M?
That is a fair point.
There's no variable in this.
I think it might be because in physics, G is gravity.
How does this have to do with physics?
Think about where maths comes from originally. It comes from like people who wanted to use that concept. So usually physicists or someone who came up with the idea. Like Isaac Newton came up with calculus when he was trying to physics. Oh no.
What was that?
My iPad is gonna die. Let me charge it.
Why did you change it that time?
I might have accidentally done it. I have no idea.
The gradient's 2.
Yeah, so we already have that.
Are we finding C over equation?
Well, yes, equation, but you can just.
So then.
Finding C is basically all of it. Yeah.
So we're just finding C.
Yeah, I mean, you already know the answer. You got the answer before. You're just trying to get it in a different way. Charging, please. I can't charge through. Okay. Please. No. Okay. Stop being nice.
Did you try flipping the end of the switch? But sometimes the charging doesn't work. It's not just right.
It's because I think I was using the power, like this thing. I was plugging the charger through that, which is.
Yeah, no, because like even if sometimes the charger doesn't work if you plug it like this way, but if you flip it, it works if you plug it in that way.
Yeah, I think it's just an issue with this. It probably can't handle like a big power running through it to charge. It can just be a.
By the way, could you please go back a bit just so I could get an idea?
What do you mean?
I need those two to go.
It's y equals mx plus c.
Yeah, I wrote that down. I just need to see like yeah, I gotta build.
You sub a point. That's all you do.
Oh, so you sub either one of them, right?
Any of them. Yeah. And then you'll get your.
Oh.
Makes sense. Yeah. Apply that to this. Awesome. And I'll be giving you a worksheet out. And for you guys online, I'll put that on Discord right now. Oh, this mouse disappears. Sorry if you lost. Okay, I'll put up the worksheets online for you guys. Oh, the iPad's turning off. It's not good.
I don't think it's doing anything.
No, I'm just turning the screen share on. Yeah. Turn the power mode off. Okay, awesome. Yeah, that's.
I didn't think you can see that.
Yeah, but you can just, you know what to do, right?
Yeah.
Yeah, these are the points. Oh, I can just zoom out on this. What am I doing?
Either way, it's just going to be the same thing.
Yeah, it's the
just
same.
0 and 5.
It's a new, not a new answer.
Yeah. 0.
You won't get a new answer. I just want you to apply this method. Here are the questions for this week. Can you pass it along? And I'll just pass it in the class. I'll give one to me for that.
Oh, wait, I did like only one.
Yep, so 2 pages per person.
Oh, wait.
Sorry, didn't have time to staple it today. So yeah, that's it for today's concepts. Now we have 10 minutes, so I'll give you 10 minutes just to work through some questions. And yeah, let me share this with my iPad. Yeah, for this week's content, questions, just work through the exercises, which is about, the zoom on this is pretty bad. Okay, that's 100%, that's better. So yeah, work through these exercises. I recommend, here's my recommendations. Let me open in GoodNotes first. My recommendations are potentially 5A, 6A, 12A, 12D. And then if you probably after doing like 5 of those, you can move on to challenges. But yeah. 5A, 6A, 12A, 12D. They're not like requirements. Like I'm not fast if you don't do these ones exactly. Again, remember, all these have solutions online. So it doesn't, no matter which one you do, you can just check your answer. Yep, so we'll go to 11. So not a long time, just spend 7 minutes. Just lock in for these 7.5 minutes. Try to get as many questions done. Then we'll do a quick recap at 11. Then we'll finish. Good. Okay. In fact, if you feel really confident from the very get-go, do one and move on to challenge if you want.
If we do the challenge, does that mean we don't have to do like 5A, 6A, stuff like that?
Yeah, so it depends. Like you should assess your level of confidence after one question.
Oh.
Right. Because I mean, if you could, you need to be able to recall all of these steps without any clues. If you can do it fully, properly, no problem, go for it. Yeah, this is all equations.
Yeah, it's annoying. You have to write everything down.
I think probably the hardest. There's only two. I think these two are probably the good ones for challenge. These two at the bottom, the challenge page. The original question is quite hard. But yeah. So here's what's going to happen. Go to 11. At 11, you're going to get 5 minutes to try to recall everything from today's lesson. Then we'll do Kahoot. I'll set up the Kahoot while you do that. And feel free to ask questions in this time as well. You guys check your answers with solutions, by the way?
The solutions.
Like,
Where were they? I just saw
on the drive, but I think you might have gone all the way up.
Yeah. I just saw the resources sheet. That's it.
So yeah, what I do recommend is have the drive link saved somewhere. Sorry, wrong one.
The Google Drive link.
Yep.
How do we access the Google Drive link? On Wednesday.
If you go to pinned messages, which I wish I knew how to do on this. How do you check pinned messages on the iPad version? Let me search that up, actually. Yeah, keep going with the question. I'll explain that after. Anyone have any questions? Feel free to let me know. Okay. Oops, sorry. Here's the list of questions if you wanted to follow these. You don't have to, again.
Is he giving us the answers in the challenge? For the original one?
Yeah.
Because it says 8. C equals -3.
No, the question asks us to find M when C is given to be -3, but for B, when C is a general value. So you need to find the answer in terms of C, which is M in terms of C, which is quite hard. That's why I want you to be...
Mx plus -3.
Yeah. Sorry?
This is going to be fun.
Yes. You have to draw a picture as well. I
Is
mean,
this part of a proof?
no proof. You need to find number, so it's not a proof.
Just to make it easier, right?
Yeah, I mean, if you try to do it without pictures, you can, but I think it'll be hard.
I'll give that a go.
Like, the thing is, don't think of picture as part of the problem. It's a problem-solving tactic. So you should not try to avoid it because you don't like it. Right?
I just hate when it takes so long to do a question.
That's where you learn. You can choose in like Olympiads, you know how long you get to do problems?
10 seconds.
No. You get 4.5 hours to solve 3 problems. That's what it should be. Being able to stick at a problem is very important. They're very hard. I don't think I could even do one in 4.5 hours.
The fact you're still there, sitting and looking at this same question for 4.5.
No, that's really good. That's why you're always constantly thinking of ideas. You're stuck. It's really frustrating, but you learn so much. I did the math competition last year. Don't get me wrong. It's nowhere near as hard as an Olympiad. That was 4 hours for 3 problems, or four problems.
So 1 hour for each problem.
Yeah, and we got 2 in the first one. It was to pair 2 of us.
Oh.
And we only got 1.5 in the second one. So it was.
So you did 3 problems in that 4 hours.
No. Sorry, we did 2.5 and then 2. Sorry, 2.5 and then 2.
So you did 2 problems.
Yeah.
In the 4 hours.
Yeah.
Yeah. Still.
This is not Olympia. This is not as hard.
How old were you when you did this?
Last year.
Oh. Wait, how old are you now?
20. Questions do work.
That's actually. What does it mean if the distance between x and y intercepts is 5? Like the distance is 5. Is that what it means?
The distance, we calculate distance in previous topics. The distance formula, using that. I don't recall without it. You can't. It's in your brain somewhere. You can think of the general. If you have 2 points, x1, x2, or y1, y2.
Oh yeah. So x1 minus x2 divided by 2. That's the distance. Was that?
That's neither, but it's closer to midpoint.
Think x2 minus x1.
It doesn't matter which one. What do you do with it?
Like so, x2 minus x1 divided by 2, comma y1 minus y2.
No, it's close to midpoint. Okay, it's 11 o'clock, so we'll wrap it up there, right? So I know you probably didn't have much time to do the problem, but you gotta start now so you can continue on that at home. What I'll do now is I'll quickly show you how you can access the solutions. I figured out how to get the pin messages on iPad. On a computer, it's a lot easier. iPad, it's as simple as this.
I don't know how to do it.
General, click the name of the chat, which is just click the top, right? And you go to pins. And then that's our only pin message. Click on it, go to the link. Google Drive. General solutions is where most solutions are because it got the textbook solutions. This is like, when you look at the question, it will say This is from Cambridge MM12. Oh, I forgot to say which chapter, which I will do. I'll add that on. Okay. I will do that straight after class. Actually, yeah. Let me fix that on all. And you go to the relevant page on this. Yep. And actually, one more thing. But the original question is not from a textbook, right? Oh my God. Why do you want me to log in, dude? Now it's being annoying. Okay, fine. Face ID? Does it even have Face ID? No. Please don't ask me for two-factor.
Do you not remember your password?
I did. Did ask me. Oh, can I use? Oh, it doesn't even recognize my face.
What's the point of having face verification if it doesn't recognize you?
I didn't set that up. I don't know. Like Apple.
Maybe it's because you're not wearing your glasses.
Maybe.
Are you wearing contacts?
No, I couldn't find them. Okay, we're in. Okay, sorry. So, what do you mean? Access. Oh, it's the wrong folder. That's why. All right. So yeah. If you take a look, general solutions are with the textbook. So if it's intro to algebra, solutions are here. Oh wait. Oh yeah, it's on the here. My bad. It's already here. Intro to algebra solutions is not in the folder. The PDF here. Okay, you go to that. You can get solutions. That textbook, solutions to Cambridge 112 is here. Now, for original questions, you go to the relevant topic. I've got a little thing called extra solutions. Do you see that? And then you simply go to the relevant section. And then you've got the answers to each of them from the section. Now, if you were quick, you might have seen the answer there for the original question. But if you didn't, that's good, because it's a good question to try. Okay?
3 something.
Don't try to remember. Oh, you're being Imal, right? Any questions? No? All right. So yeah. Actually, these are some marginal gains you can focus on. So I think the reflection this week is really important, because I've said some very important tips that I know you might be new to you guys, which is first, active recall. So reflect on how you're going to implement that within your homework. Reflect on also using the solutions to check your answers, right? Because they're important. Knowing what you do wrong is super important. So if you don't check your answers with solutions, you're sort of losing out on some of that benefit. Okay. All right. Yeah. So what I'll do now is 5 minutes for you guys to do a recall. Recall everything we learned today, all the processes. Try to if you finish that, try to do the question from the recap. That's pretty tricky without our help. But yeah, just try to recall whatever you can. Okay. Think of it as a blurt. You're blurting out whatever you can onto a piece of paper for 5 minutes. 11:06. And in that time, what I'm going to do is I'm going to set up the Kahoot. Okay. Stop the recording.